Welcome everybody to the third video in our DMM series here. And we are going to go ahead and get into the ins and outs of resistance measurements. And so if you're looking at your DMM, all of those measurements, as I discussed before, are at the top of the dial. Okay, and you've got the smallest range is from 0 to 200, and the highest range is up to 200 meg. Okay. And so I've got a few resistors here. If I pan back out, I've got a few resistors that I'm going to be measuring right now. Just some fixed resistors. When I say fixed, I mean like this, the carbon copy, or there's some surface mount, that kind of thing. If the value doesn't change, if the value is static, in other words, it's always 1K, it's not variable. So that's these four fixed resistors right here, okay? Now let's say that I didn't know what each of these values were, okay? And I wanted to make sure I got the best measurement possible. What I'm trying to do with the multimeter is I want to display as many digits as possible to give me the best, what I call, and what we in metrology call, the best resolution possible. In some cases, it's going to be 3 digits is the best that you can do. In some cases, you can actually have 3.5 digits, and I'll explain the half digit shortly. So anyway, the first one, excuse me, should have a cough button set up here. So the first resistor I'm going to measure here, let's see, what is this? This color is green, blue, red. Let me focus in on that so you can see it. Green, blue, red with a tolerance band of gold. I believe all of the resistors in your box are gold. I don't believe they've mixed them up or have any silver or anything like that. So all of these are going to be plus or minus 5%. So that's my first resistor here, is green, blue, red, which green is 5, blue is 6. So this is 5, 6 times red is 2, so that's 2 to the second. I'm sorry, 10 to the second. So that's essentially a 5.6K ohm resistor, plus or minus 5%. Okay? So I know what range that I should be in, but what I'm going to do is assume that I didn't. And what I'm going to do is I'm going to start in the highest range reasonably. I'm just going to go up to the 200K ohm range. As soon as I back out, refocus. Okay. And when I go to make a resistance measurement on one of these fixed resistors, notice how I have the control here. When I put the body between my thumb and my forefinger and I roll it here, I have control over, where those legs sit. Right? So what I do is I take my other hand, and because because the resistance measurement is not polarized, it doesn't matter which of these I put on which side. Okay, it doesn't matter if I go this way or if I go this way. I just do whatever feels comfortable in my hand. I make sure that let me zoom in on this, make sure that my red lead is over here at the volts and the resistance part. Okay. And then I take the resistor between my thumb and forefinger, I put the leads on either side of my finger, and then I just give it enough force to where it stays firm. So you can see in the 200K ohm range, it's measuring it. I know what it is. It's 5.5 kilo ohms. Now that only gives me 2 digits. Okay, I don't count that leading 0. All right, so I'm going to go down to the next range, 20K. And I think this is going to be the best range possible because 5.5K is greater than 2K. So if I were to put it down there, it's not even going to register. Okay, and we saw that 200K wasn't enough. It only gave us 2 digits. So the best range is going to be this 20K. So let's see what happens now. Now it's reading 5.56K. So that tells us a little bit more information than we were getting before. Okay. We know that there's another 60 ohms, and that may be crucial depending on what we're doing. So you always want to make the best measurement possible. In this case, the best we can do is just 3 digits, okay? Now, If we were, I'll go ahead and do this. If we were to put it down into the 2K ohm range, you can see that it's not even going to register, okay? So this, for this particular resistor, is the best range, okay? Now let's go to the next one here. This one is, excuse me, this is brown, red, red, okay? Brown is 1, red is 2, and then red in the multiplier is 100. So essentially we've got a 1.2 kilo ohm resistor, okay? Now, 1.2 is greater than 200, and it's less than 2K. So I'm going to say the 2K is going to be the best one for us to look in. But I'm going to start once again up here in the 200K and show you the difference between the different ranges, okay? So this is the 200K making a measurement. We get a resolution of 1.1, so we get 2 digits of resolution. So 1.1 kilo ohms. Now let's move it down to the 20K and see how that changes. Okay, now it's telling us 1.17 kilo ohms. So that's a little bit more information. Now let's take it down to the 2K. This is the one I predicted would be the best. Okay. So you can see it looks like we have 4 digits of resolution, and technically we do. However, that front leading one, oh, there went my, should come back, there it is. All right. So that front leading digit can either be blank or it can be a 1. It's not even a 0. Okay, so you can tell if we were, you know, when we were making the, I guess I can do it now, the 1K measurement, I'll redo that one here in a second. But anyway, 1.182, so there we go. There's the 3.5 digits total that this thing will output. That's better than what we got with the 5.5K, but that was the best we could do with that one. With this one, we were able to get all the digits on there, so that's a really good measurement. Okay, now I just referenced it, so let's look at the 1K. Brown, black, red. Brown is 1, black is 0, red is 100, so that's 10 times 100, which is 1K. And so this is in the same range, right? This is the best range for this one, but you see that there's no leading digit there. So, you know, because that digit can only express a 0 or a 1, you know, I wouldn't call it a significant digit in this one. So really, the best we could do is 3 digits for a 1K. Okay, so it just depends on what the nominal value is of each resistor as to which range is going to be the best. Okay, now let's look at this last one. And I got to reset the camera here. It's still framed on me. Now we should be good. Do we have movement? Now we have movement. Okay, I apologize for that. So now this time, just to recap with the 1K ohm resistor, okay, in the 2K ohm range, 986 ohms. Okay, so the best I can do is those 3 digits, right? Whereas when I had the 1.2K, I was actually able to get 4 digits of resolution. Okay, but technically that leading one there can only be either a 0 or a 1. Okay, the last one here is a 2-tube, a red brown, which is 22 times 10 to the first is 10. So this should be 220 ohms. Okay, now if I'm down in the 200 ohm range, I'm not going to get anything because 220 is higher than 200. So I go to the 2K range. This one should be a pretty good measurement also. Right? 217 ohms. But notice I'm in the 2K range, so again, it reports it as a kilo ohm. Right? Now, if I take it up to the 20K range, I get less resolution, 0.21K. Take it up to the 200K range, even less resolution, 0.1. That's not even close. What happens if I go up to the 2 meg Well, now I'm completely outside and it registers as 0. So the range matters, right? You want to try to get the best resolution from whatever range that you are using, okay? Now, let's go ahead and talk about these potentiometers, the variable resistors. Okay, so the first one I'm going to look at, which I don't know how good I can do on this here. We'll try. It still may be a little too close. I think we can see that it says 503 on the top there. Oh, maybe I need to go back just, there we go. So 503, that's 50 kiloohms. And I know that because it's 50, and then the 3 represents 10 to the 3. Okay, 10 to the third. So this is a 50 k ohm potentiometer, all right? Now something to remember about the potentiometer, it's a 3-terminal device, okay? And I typically label those terminals A, B, C, like you see them left to right. Doesn't really matter A or C. What matters is if you were to measure from the outside terminals, okay, you should, no matter what position the variable part is in, no matter what position that is in, you should get 50 kiloohms because that's the nominal value. And so regardless of where the wiper is, okay, that's what we call the wiper, no matter where that is, you're always going to get the nominal value. Now, between A and B, okay, that's one resistance measurement, and then from the middle to the outside is another resistance measurement. And essentially what it's doing is it's taking that nominal value and splitting it, not in two, but in whatever proportion the wiper sits in. So if this is a 50K and I measured 10K from A to B, that left terminal to the middle terminal, if I measured 10K, then that means from the middle terminal to the outer right terminal, that should measure 40K because those two measurements have to add up to whatever the total is, okay? So the first measurement I'm going to make, I'm going to do this in the 200K because I think that's the best resolution for this particular, resistor. And let's go ahead and get back zoomed out so we can see the screen. And all I'm going to do is just measure those two outer terminals there. One here, one here. So there we go. Mine measured 50.5 kiloohms, right? And that's regardless of where this wiper that turns left and right, that's regardless of where this is. Okay, now, I'm going to try to feel out where I think halfway is roughly. All right. So now what I'm going to do is I'm going to measure the middle and the outside, and this is going to be, I may want to set up something on my breadboard, but let me see if I can do this here. If I can mash that one there and just get to the inside. There we go. So one side is 20.5, and then I do the other side. I think I just did the same. I think I just went 360. Nope, the other side is, whoops. Be careful with these terminals. And the other side is 30K. So I have one side at 20.1 and the other side at 30K. And if you saw, it was a 50.5. Okay, so there is some tiny little variability in there. It's not going to be exactly the same both times. And so, but that's how you measure the potentiometer. Okay, and you've got a couple of those in your kit. What I was saying about putting them in the board, you know, putting it in like that. And then having a wire that comes off maybe the left side. This is probably the safer way to do this so that you don't bend your pins too much. Wow, I really got that sucker in there. I can't get it out. Oh, there we go. Mercy. Okay. So now here's from one side to the middle. And I just attach. You can do this with the clips too. 20.4 on that side. I take one of these, move it to the other Measure them again. I should get my 30 this time. There we go. And you know, you can work on turning this left and right and see how that changes. You know, from A to B and from B to C. But on the outside, if I measure the outside again, I should get my total 50. There we go. So it's even so, being in the board is making it measure just a little bit different than when it was in my hand. But I was also introducing some air in that case too, right? So when I'm doing this right now, I'm putting my finger against it, and that's increasing the heat of this conductor, which is going to change the resistance slightly. So, you know, obviously the best thing to do here would be to have alligator clips. So you could have one alligator clip here, and I'll just use white because that's what I got left over now. So I want to leave my other colors for the board. So now, essentially, this becomes the end of my probe, and now I can just attach them here, and there we go. So there's the outside. So there's with me not touching it again. I'm not introducing any human air, and now I am measuring. Gosh, that was like a 3,000 ohm difference when I had my fingers on it versus not. And so now I can, you know, here is A to B. That's 42.2. And if I go, now this side should be about 8 or so. Okay, let's pull it down. Whoops, I think I missed here. From here to here, and here to here. There we go. So that side is 8.5. And then again, if I pull it to the outsides, I get my full 50.5. Okay, and you can see, if I have it on the outside right now, but as I turn this and change it, okay, this one's pretty steady. Sometimes the value will change. So anyway, that is how you measure a potentiometer, and you know the different terminals that are involved. Okay, and I don't think I need to show anything else in terms of measuring resistance. Notice that all of this was done without any power to any part of the circuit. Okay, and yeah. Now, the last thing I want to talk about here is measuring resistance in series. Okay, so now we're going to have to go to the breadboard for a minute while I construct this, because this gets into Chapter 4 and Chapter 5. Okay, so one of the things you're going to have to do when you have 3 resistors in series, let's say, I'm going to go ahead and build that circuit. Doesn't matter what these resistance values are, I can figure that out later. So there's the 1K anyway. Here is, this was the, I guess this is the 220 ohm in series. So that's about 1.2K total. Get rid of that. And then I'll put a third one here. This is the brown, so that's the 1.2K. So this should be 2.4 total. So that's what Chapter 5 teaches us, right? That you, when you have resistors that are in series with each other, okay? And this is in series. If we can adjust, whoop. Now the power to this, if we get rid of these, because I'm not making that measurement right now, the power to this would go from the positive to this one terminal here, and then the negative would go from this terminal out here down to the negative, okay, to make a complete circuit. But anyway, if I just wanted to do, you know, what's the total resistance in this circuit, okay? Because they're all connected together, now I do want to measure them while they're on the board, okay? So I'm going to leave it like this. I'm going to take my resistance probes, quote unquote, right, because I've got it set up still to measure like this. I'm going to put this in frame. Back out here so you can see the measurement. Oh, I timed out. Okay, so I am expecting 2.4, so I'm going to go down to the 20K range. Okay, so I just put one side of this in over here. Okay, and then I'm going to put the other one on the other side. Okay, so that gives me 2.38 kiloohms. Okay, so again, I am measuring all three of those added together. Okay, so again, in Chapter 5, when you add series resistors together, you're finding the total resistance of the circuit instead of just having an individual single resistor like Chapter 4. Chapter 5, you can have as many resistors in series as you want. In fact, I could go ahead and add another resistor in series here that we just used, and that was this one. And let's see, this one was 5.6K. So I think I'm still in the proper range, but let's go ahead and see what that is added in. So adding that one in series gives us 7.96 kiloohms. So those are the four resistors I used. And if you wanted a more accurate measurement of your series circuit for the calculations, you could also measure what value the battery has when it's under load conditions. Okay, so if I were to complete this circuit and then hook all of this up, I could measure the battery. You know, I could put this in volts. Right, I don't have two other pieces of wire handy, or I would just do it. But I could then put that down here and this one up here. Whoops, up here, anywhere, it doesn't matter where, right? We talked about that last time. Put those anywhere up there, and that will measure the voltage, right, while it's under load conditions. Because that value, so see right now it says 9.5 volts. Well, I'll tell you what, we'll just plug this one directly in here, since we don't have the extra wire cut already. And I'm just going to plug this directly in. That means that this would go here to measure that first node, and then here. I have to be on the same node as that. So you can see under load conditions now, if I back this up, so I've got the circuit running, and I've got a voltage measurement going on around the voltage source, right, around the whole circuit, and I'm measuring 9.44 volts. So watch what happens when I remove the power. Okay, well, for one thing, it goes away, right? So this is a bad setup for me to use these like switches. But, okay, how about this? If I take out and break the circuit here, okay? So now it's not under load condition, and it's going back up. It went back up. So in all of this, I must have burned out another 10 millivolts, but so now it's gone back up to 9.49. So that's still a 50 millivolt difference that's being dropped inside the battery as this thing is running. Okay, so it's getting itself back up to 9.5 volts potential here. It's right on the border, but you know, regardless, when it's under load conditions, and I could just put one resistor in here, that would be enough to do it. So put this resistor in here. It's going to drop the same voltage no matter what the value is. The current is the only thing that's changing. So there you go. So now it's down to 9.09. Okay. So like I said, it just matters. You know, you want to take that into account. So if I were to measure the voltage right now, that's not necessarily what it's going to be under load conditions. Okay. All right. I think that concludes this third video. Thanks for watching.